Using fog and depth of field can really help to tell your story by creating atmosphere and mood, especially when working with a still frame like for the RenderMan challenge. In this video, I'll show you how these elements can be added to your Katana project. The PRMan volume node can be used to add volumes to your scene, either by creating them inside Katana or importing a VDB that you've exported from another application. This node can be merged into your scene and transformed into position. In this case, we want to add some constant fog, so I'll scale it up to cover the whole scene. Before seeing the fog in our render, we need to assign a material, which we can do in the Network Material Create parameters by clicking the plus and choosing Network Material and then renaming it. Let's quickly assign this material to the volume we've created by adding a new material assign and dragging the volume and the material over to the relevant fields. Then we can jump inside the Network Material Create and add a Pixar volume node. Pixar volume is a RenderMan material that can be used to render volumetric effects. As soon as we connect this volume material to the material output, we should see the render update with the fog. At the moment it's very dense, so the render appears dark. We can reduce the density float to bring that density down to something that we like the look of. And we can also adjust the diffuse color to bring out a bit of warmth. And you can see what a difference this has made to our render with just a couple of nodes. I'll disable the fog for now while we look at rendering depth of field. Depth of field can be rendered directly in Katana, or you can render a depth pass to add it later on in comp. I'll show you how to set up both. To render a depth pass, we need to set up an AOV, which is done using two nodes, the PRMan output channel define and the render output define. In the PRMan output channel define, we can give this a name, so I'll call it Z, set the type to float, and add a source with the value float Z. This is a built-in AOV, so we need to make sure that there are no typos here. Now in the render output define, I'll name the output Z as well, and then we can choose the Z channel from the dropdown to link it all up. Now we have our Z depth pass set up, we can ensure it'll render by selecting it or choosing all from the interactive outputs dropdown in the render settings. And if we set off a render, we can see our depth pass in the monitor layer or the monitor tab. You can hold Control and the up or down arrow keys to adjust the display so you can get a better idea of how this is looking. Once this is exported, it can be used to add your depth of field in comp. We'll go into more detail about AOV setup in a later video, but for now this is all we need to work with depth of field. To render out your image with depth of field from Katana, we need to use a PRMan camera settings node to access the camera options, including depth of field. Make sure that the location path points to your camera location in the Scene Explorer, and then add a Pixar camera projection shader from the drop-down list. Then we can go ahead and adjust the f-stop, the focal length, and the focal distance to get the result we're after. If you're not quite sure on the focal distance, a cool trick to find out an object's distance from the camera is to use the pixel probe in the monitor. This is toggled with this button or the full stop key. This tool can be used to view information about a chosen pixel, such as the RGB values, the geometry, or if you're viewing the Z-depth pass, you can use it to find an object's distance from the camera. So, for example, if we want the sign to be in focus, we can drag the pixel probe over here to the sign and grab the value from here. So it's about 45, or we can copy and paste this value if we need to be exact. You can play around with the f-stop and the focal length values to achieve the desired look. Lower f-stop values will narrow the depth of field, making objects that are further from the focal point appear more blurry, and vice versa. The ratio of the focal length to the f-stop determines the size of the lens aperture and therefore the amount of blur. So a lower focal length equals less blur and a higher focal length equals more blur. Once we're happy, we can enable the fog again and see how this is all looking together. And you can see what an impact this has to the look and feel of our image. Keep an eye out for more Katana quick tips to help you along the way with the RenderMan challenge.